All right, today we're going to deconstruct a really powerful machine learning model. It's designed to solve a huge problem for pretty much any business, figuring out which customers are about to leave. And this isn't just one simple algorithm. It's a super clever multi-step strategy. Let's dive right in.
But first, let's ask the big question. Why is this so tough? I mean, predicting which customers are going to pack up and leave sounds like it should be straightforward, right? You might think, hey, just throw more data at it. But it's not that simple. The real problem is actually the kind of data you're working with.
And that brings us to the core of the issue: imbalanced data. Think about it. For most businesses, the vast majority of their customers are happy, they stick around. The folks who actually leave, the churners, they're this tiny, tiny minority. So your model is basically searching for a needle in a haystack, and, most standard algorithms are just terrible at that.
So, here's how we're going to break this down. First, we'll dig into that churn problem. Then, we'll introduce this cool multi-strategy solution. We'll walk through 3 key steps: filtering features, balancing the data, and training the model. And finally, we'll see how it all comes together with the results. Okay, so let's really dig into this imbalanced data thing. Imagine you have 100 customers, and only say 2 of them are going to leave. A really lazy model could just predict nobody leaves for everyone. And guess what? It'd be 98% accurate. Sounds great on a report, but it's totally useless for the business, right? Because the whole point is to find those 2 specific customers who are about to walk out the door.
And that's why you can't just use a one-trick pony for this. You need something smarter. Enter the IADASYN FLCatBoost model. Now this thing is brilliant because it understands that a fancy algorithm is totally worthless if your data's a mess. So it attacks the problem from both sides. First, it fixes the data itself, and then it brings in a specialized algorithm to do the learning.
The whole process really boils down to this clean 3-step blueprint. Step 1, we filter our data to keep only the most predictive information. Step 2, we balance the dataset to fix that huge imbalance. And step 3, we finally train our model. That's the master plan we're going to walk through right now. All right, let's jump into step 1, filtering. It's kind of like cooking, You got to pick the best ingredients before you even think about turning on the stove. In machine learning, this means we need to find the customer details, the features that actually tell us something about churn, and just toss out all the random noise. And this model has a really clever 2-part system for doing exactly that.
So here's how this double filter works. First up, we have something called an elastic network. Think of it as the bouncer at a club. It takes a quick look at all the features, tells the weak ones to shrink down, and kicks out the totally irrelevant ones. Then, whatever's left gets to move on to the second tier. Here, a super powerful algorithm called XGBoost lines them all up and ranks them from most to least important. What you're left with is just the good stuff, a clean, powerful subset of data to work with.
Okay, so we've filtered our features, check. Now it's time to face the main event, that pesky data imbalance itself. And that brings us to step 2, which is honestly where the magic really happens. See, a simple way to fix imbalance is to just copy-paste your few churner examples over and over. But that's a terrible idea. It leads to all sorts of problems. Instead, we're using a technique called IADASYN. This isn't about copying. It's about intelligently creating brand new, super realistic, synthetic examples of churn customers. It's like giving our model a much richer textbook to study from.
So what makes this IADASYN so special? Well, the I literally stands for improved. The older version was okay, but it could get fooled by weird, noisy data points. This new version has 2 major upgrades. First, it cleans house before it starts creating data, using an algorithm called LUF to get rid of outliers. And second, it knows how to handle things like gender or education level way more intelligently, which makes the new data it creates so much more believable and useful.
So what the heck is this local outlier factor, or LOF? I love this analogy. Imagine you're in a crowded room, and you're looking for the person standing all by themselves in a corner. That's what LOF does with data. It looks at each data point and asks, hey, is this point way more isolated than all its neighbors? If the answer is yes, it flags it as an outlier, basically noise, and gets rid of it. It's a super smart way to tidy up the data before the next step.
Awesome. So we've filtered out the noise. Check. We've intelligently balanced our dataset. Check. We are now officially ready for the final step in our blueprint, training the actual model on this beautiful, clean, perfectly prepped data.
And that brings us to the grand finale. Step 3, training with FLCatBoost. Now, CatBoost on its own is already a beast of an algorithm, really top tier. But this version has a special tweak, a secret weapon that makes it perfect for our problem.
It's been engineered to basically ignore the easy stuff and focus all its brain power on the really difficult cases.
And right here is the secret sauce. A normal CatBoost model treats every mistake as equally important. But with our data, that's a huge problem. It would spend all its time getting the thousands of easy-to-predict non-churners right and just ignore the hard part. FLCatBoost swaps that out for something called focal loss, and this is a total game changer. Focal loss essentially tells the model, hey, see all those easy customers? Stop worrying about them so much. I want you to focus all your energy on these few really tricky churn customers. It's like giving the model a magnifying glass for the most important part of the problem.
Okay, so let's recap. We've gone through this whole meticulous process. We filtered features with a two-tiered system, we intelligently created new data with IADASYN, and we trained a highly specialized classifier with FLCatBoost. So, the moment of truth. After all that work, how did it actually do?
Well, the results really do speak for themselves. This chart is showing a score called AUPRC, which is just a way of measuring how good the model is at finding the rare churn cases without crying wolf all the time. And as you can clearly see, our complete IADASYN FLCatBoost model just blows the others out of the water. It beats the standard XGBoost, and it even beats a regular CatBoost. It just goes to show you that all that careful prep work on the data paid off. Big time.
Let's just put a number on that performance for a second. 97.51%. Look, in this field, when you're dealing with imbalanced data, getting an AUPRC score that high is, well, it's absolutely remarkable. It means the model is really, really good at both finding the customers who need attention and not making a bunch of false alarms.
So what's the big takeaway from all of this? It's that solving these really tough data problems, it's not about finding some single magic algorithm you just download and run. It's about building a thoughtful, strategic process. It's about the combination, filtering out the noise, then intelligently balancing the data, and finally training an algorithm that knows where to focus. That whole pipeline is what gets you these incredible results. And that leaves us with a really exciting final thought. This whole filter, balance, focus strategy, it completely nailed customer churn. But what other incredibly difficult, imbalanced problems could it solve? Think about finding that one fraudulent credit card swipe among millions of normal ones, or spotting the early signs of a rare disease from medical scans. Any problem, where you're searching for that needle in a giant haystack. This kind of powerful approach could be the key to solving it.